Morning, pre-calers. How are you? We are starting week 2 of online learning. I hope everything went well with your first week, and please reach out to me if you have any questions. This week we'll be doing Zoom, so there'll be more information about that. Okay, so this week we're doing identities, and this is an area of math that is like doing puzzles. During this time especially, probably if some of you are playing online games like Sudokus or 2040 or just all these different mind games, that's exactly what this is. Like, these are like little puzzles that you try to simplify, and you have to follow the rules of the game. So you start by doing these identities. And because I teach calculus, I know that you have to be able to manipulate these to simplify them in order to do calculus with them. So that's kind of why you do them. But think of this as brain exercises, okay? This section, we have 2 weeks on trig identities, and think of them as brain exercises. So the first set of identities you already should know. We already know our reciprocal identities, okay? We spent a lot of time learning what cosecant, secant, and cotangent is. What this is going to allow us to do is replace it. If you see cosecant and you want to rewrite it as 1 over sine, you can, because they're the exact same thing. Anytime there's an equal sign like this, you can replace. So cosecant can be replaced with 1 over sine. Secant can be replaced with 1 over cosine. Cotangent can be replaced with 1 over tangent. Similarly, sine could be replaced with 1 over cosecant. Cosine could be replaced with 1 over secant and 1 over cotangent. Okay, all those can be replaced either way. So you already knew those. Hopefully you already knew quotient identities as well. You may not have, but you don't have to have these memorized. You're going to have this sheet that you can use anytime you want. But tangent is the same as sine over cosine. We know that tangent is y over x. Everybody knows that tangent is y over x. And so y is sine and x is cosine. So it follows that tangent would be sine over cosine. So if you ever see tangent and you want to replace it with sine over cosine, you can. They're the same thing. Similarly, cotangent can be replaced with cosine over sine. Okay? Now, these are what we call the Pythagorean. These are a big deal. We'll use these a lot. I really like them. And the first one is what I used to have a teacher friend that taught here, and she was pre-cal, really hard teacher. Miss Russell was her name, and she called this one right here Big Daddy, because he's like the father of all of them. And it says that sine squared plus cosine squared equals 1, and that's a true fact. So if you have sine squared plus cosine squared, you can replace it with the number 1. The reason for that is if you come over here and look at this right triangle I'm forming, the x value is the cosine value, the y value is the sine value, and the hypotenuse on the unit circle is 1. Well, we all know Pythagorean theorem, a squared plus b squared equals c squared, and that's all that we used right here. And then to get the other ones, if we were to divide both of these things by, divide both sides by cosine squared, sine over cosine is tangent, so that would be tangent squared. Cosine squared over cosine squared is 1. And then 1 over cosine squared is secant. So if you divide each term separately here by cosine squared, you would get this middle one. And then if you divide each term separately of this first guy, oops, that didn't erase. If you divide each of these terms by cosine squared, whoops, that's what I already did. Sine squared, sine over sine. Anything over itself is 1. Cosine over sine. Cosine over sine, we've got it right here. It's tangent. Since these are squared, this is squared. 1 over sine. 1 over sine, look right here, it's cosecant. So you get that one. So that's where those 3 come from. And these are the identities that we're going to be using today to manipulate and rearrange things and simplify things, okay? Now, here's some of the steps, and again, you can have this list and be using it all the time, but these are the things that you do to manipulate, like the rules of the game. You look for algebraic things to do. If you have fractions, you want to get a common denominator and add them. If you can factor, you always want to factor, maybe pull out a common term or factor a binomial, difference of squares. You want to multiply by a clever form of 1. 7 over 7 is a clever form of 1. Sine squared over sine squared is a clever form of 1. You want to multiply or factor conjugates. So a plus b times a minus b. If you were to FOIL that out, the middle terms always cancel, and you get a squared minus b squared. Or you factor the difference of squares. So if you started with something like a squared minus b squared, you could factor that to a plus b and a minus b, either way. Okay, you want to look for trick things to do. If there's squareds, you want to look at those Pythagorean identities, and you can manipulate them and move them around. Keep looking, keep trying, and see if you're headed in the right direction. Is it getting simpler? Is it getting more complicated? And you can always change everything to sine and cosine if all else fails. So what I'm going to do is I'm going to do the evens on this worksheet for you right now, and then the odds will be your homework. The first thing I did is I copied and pasted the section that we're doing for today. Let's pick a fun color. What color should we pick? I don't like my options here. Oh, here we go. Let's do turquoise. Okay, so I copied and pasted. These are the ones that you need to know. And like I said, you don't have to have them memorized. You just need to use them. So we're trying to simplify. The key word here is simplify. And all of these simplify down to like one word, okay? So we're going to use some of our identities, make some substitutions, and simplify. Well, cosine, there's not a whole lot you can do to cosine. These, by the way, are being multiplied together, so multiplication is important to understand there. Cosine can be written as 1 over secant, but I don't know. Let's look at the tangent. What can tangent be rewritten as? Tangent can be written as sine over cosine. So this could become cosine theta times sine theta over cosine theta. Now remember, this is understood to be 1, and when you're multiplying, you can cancel factors. You can only cancel factors, things being multiplied. So cancel, cancel, and we get sine theta. So cosine times tangent is the same thing as sine. Okay, next one, I see squareds. It told me in the notes up above that if you see squareds, think of the Pythagoreans. So I've got them right here, okay? Well, it doesn't match exactly. This says sine squared plus cosine squared is 1. But what if I were to manipulate this? And what if I were to say subtract cosine squared from both sides of the equal sign? Here's the equal sign. I would be left with sine squared theta equals 1 minus cosine squared theta. And that's another form of this identity that you can use. Voila, I see 1 minus cosine squared. This tells me it's equal to sine squared. I am done with this problem. Boom. Anytime you see 1 minus cosine squared, it equals sine squared. Done. Simplified. Okay? All right. Number 6. Secant x minus 1 times secant x plus 1. Let's go back and look at our list and see if any of that looks familiar on these little hints of things to do. Okay, well, look at multiply out the conjugates. If I were to multiply those two, that's exactly what it looks like. It's a squared minus b squared. Now, if you've forgotten, I'll go ahead and FOIL. You would not have to do this. You could just know it, but let's just show first times first. Anything times itself is squared, so that's secant squared. Outside is plus secant. Inside is minus secant x. And then last is minus 1. Well, what happens is the plus and the minus drop out. So you end up with secant squared. Whoops. I wrote that weird. Sorry. Secant squared x minus 1. And then you try to simplify. I see a squared, so let's look at the Pythagoreans. This one has secant. If I subtracted 1 from both sides, I would get tangent squared theta equals secant squared theta minus 1. And I can replace tangent, secant squared minus 1 with tangent. So this is going to be equal to tangent squared x. Yay! Okay, so we just multiplied out. You didn't have to show that work. You could go straight from here to here because that's just multiplying conjugates that I showed you above. All right, ooh, this one scares me. I don't like how complicated this whole fraction looks. Yowza. Well, let's try to simplify it. Okay, this is a division sign, and division turns into multiplying by the reciprocal. So this could be written as 1 minus sine squared theta times 1 over tangent squared theta. Does everyone agree? Division is the same as multiplying by the reciprocal, okay? Well, what is 1 over tangent? Let's go back and look at our list. You can always look at this. What can I do with 1 over tangent? Well, I see it on here. I see it right here. 1 over tangent is the same thing as cotangent. And since this is squared, I would have to make it squared. So this would be, 1 minus sine squared theta times cotangent squared theta. That doesn't seem that much better, but maybe there's something I can do with the cotangent. So I go up here, cotangent, cotangent. I don't want 1 over tangent, but what about this? It's cosine over sine, okay? So maybe if I rewrite cotangent as cosine over sine, something might be better. And remember, if it's squared, it stays squared. So 1 minus sine squared, and then this is cosine squared over sine squared. You can always put something over 1. Since this is multiplication, the factors cancel, and I get 1 minus cosine squared, and we've seen that before. And remember, that was equal to sine squared. Remember, we did that right here. Yeah? Okay. How you doing? Couple more problems. I'm going to keep plugging ahead. You can pause as you need, but I'm going to go through. All right, this guy, I've got a term out in front being multiplied times 2 terms. What I think I might do is distribute. That was one of the ideas. Distribute was one of the ideas up here. See, it's right. I don't know why it's not highlighted, but distribute was an idea, right? Okay. So if I distribute, I would get cosine theta times secant theta minus cosine squared. Anything times itself is squared. Okay, what do I do with this secant? Well, secant, if I look at my list, you can always keep scrolling back up and look. Secant is 1 over cosine, okay? So I'm going to rewrite this as cosine theta times 1 over cosine theta minus cosine squared. Those cancel, so you get 1 minus cosine squared theta, and we've seen that a couple times already, and it's sine squared. Notice these have all simplified down to like one thing. Boom, one term. Okay. Oh, this one looks a little more challenging. It doesn't matter how you do it. I see 3 things being multiplied. This is a factor, this is a factor, this is a factor. This has 2 terms, this has 2 terms, and this only has 1. So I'm going to take this term with 1 and just distribute it to the middle term and see what happens. So I guess I just leave the 1 minus cosine x, and I'm going to distribute. So cosine times 1 is cosine, plus cosine times secant is cosine times secant. Will this simplify? Well, yes, because cosine, secant is 1 over cosine, so that cancels. So I get 1 minus cosine x. That first term stays the same. This becomes cosine x and then plus 1 because this cancels. Now I'm going to multiply it out again. So I'm going to FOIL. If you see a shortcut, that's okay. The first term times the first term is cosine x. The last times the last is 1. The middle is minus cosine squared x. And last times the last is minus cosine x. So what drops out is the positive cosine x and the minus cosine x. And I'm left with 1 minus cosine squared. Oh, we keep seeing that one. And that is sine squared. Yay. All right, last one, guys. We can do it. This one, yowza. I don't like this. This seems pretty complicated down here. And I wish I could get rid of it. I don't know what to do with this tangent squared, but I know it's a squared, so I'm going to look at my Pythagoreans. So let's go back and look at our Pythagoreans. Okay, tangent squared. Okay, well, look, we figured out that tangent squared, tangent squared equals secant squared minus 1. I like that because it involves secant, and that's what I saw already on the problem. So maybe something will happen. So I'm going to rewrite my tangent squared as secant squared theta minus 1 over secant squared, just secant theta, sorry. Oh my goodness, spastic, excuse me. Secant theta plus 1. Now, and there's a plus 1 out there. Now, y'all are going to want to cancel. No, 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 no. You can only cancel factors. Factors are things being multiplied. This has got a minus, this has got a plus. So you cannot cancel unless they're being multiplied. But I can factor this top thing. It's the difference of squares. Okay, let's go back up here. I want to show you something up here. So right here, if we have a squared minus b squared, we know that it's always equal to a plus b times a minus b. That's factoring the difference of squares. If we do that on this problem, it's going to be super helpful. I can rewrite the secant squared as secant theta plus 1 times secant theta minus 1. All of that is over secant theta plus 1, and then there's a plus 1. Well, now you can cancel because this entire thing matches this factor because they're being multiplied. So I get secant theta minus 1 and then plus 1. And then what happens to my 1's? Plus 1 and minus 1 cancel. So I end up with just secant theta. And you are not required to do, well, wait a minute. You need to go to here. Fill that in again one more time to make you think. List all the reciprocal ones on the homework and the ratios and then the Pythagorean, and then that will be all you have to do.